हेलो स्टूडेंट्स, वेलकम इन माय यूट्यूब चैनल। अब तक हमने 4 लेक्चर में देखा कि किस तरह से एमाइन कंपाउंड का नोमेनक्लेचर होता है, स्ट्रक्चर किस तरह से दिया जाता है, एमाइन कंपाउंड के सेपरेशन किस तरह से किया जाता है। आज के लेक्चर में हम पढ़ेंगे कि किस तरह से एमाइन कंपाउंड को प्रिपेयर किया जाता है। देयर आर 10 डिफरेंट मेथड फॉर द प्रिपरेशन ऑफ एमाइन। First method is reduction of nitro compound. Second is ammonolysis of halide. Third is reaction of alcohol with ammonia. Fourth is from carbonyl compound. Fifth is reduction of nitrile compounds. Sixth, reduction of amine. Then 4 are specific method. Gabriel-Thielemann synthesis, Hofmann reactions or Hofmann rearrangement reactions, Curtius reactions and Schmidt reactions. By using this 10 different method, one can prepare amine compound. So now one by one we will start this different method. Now first method, reduction of nitro compound. Now nitro compound can be reduced into amine by using a different catalyst. So first method, reduction of nitro compound. Now general reactions, when nitro compound we have, then this is the general formula of nitro compounds. Now nitro compound reduction requires 3 mole of hydrogen gas, and by reduction of this nitro compound, this oxygen react with hydrogen, it remove in the form of water molecule. So 2 molecules of water we are getting a byproduct, and reduction give us a amine. Now for this reduction reactions, variety of catalyst we can use. Suppose here R equal to alkyl nitro compound. If this compound are alkyl nitro compound, then for reduction of alkyl nitro compound, we can use lithium aluminium hydride as a reducing agent, or one can use sodium borohydride. Now nowadays there are different type of metal can be also used for as a reducing agent, but temperature required for reduction process will be high. For example, we can use this nickel, then sometime combination of platinum metal, then palladium with a charcoal. These are the can be used with a reduction purpose. This all different type of metal can be used for reduction purpose. Now nowadays metal and acid combinations. Metal and acid combination is very well famous for reduction of nitro group. And metal and acid, generally one can use a tin and HCl combination. Then after very easy and cheap combination, that iron scrap with a concentrated HCl. Iron scrap with concentrated HCl is used in a large proportion for reduction of metal. So these are the different type of reducing agent which one can use for reduction of nitro compound into amine. Now suppose we have a nitromethane. Then this nitromethane reduction, suppose we have carried out by using a platinum as a metal reducing agent. Then by use of this platinum, this oxygen combined with hydrogen and it remove in the form of a water molecules. Total 2 water molecule will be obtained, and in a place of oxygen, hydrogen will enter. So as a result, we will get a methylamine, or it is considered or known as a methanamine. So by using this variety of method, one can prepare nitro compound. Suppose you have nitroethane, CH3, CH2, NO2. This structure you are knowing very well. It is known as a nitroethane. Now this nitroethane also can be reduced by using this, but one can use this palladium charcoal combination for reduction purpose. Ethanol we are using as a solvent. When we use this thing, oxygen, same method, remove in the form of water molecule, and through this reduction, oxygen is replaced by hydrogen, and as a result, we get this structure. Now it is a 2 carbon atom, so you are knowing very well. Name of this structure is ethanamine. Now, suppose we have a different type of aromatic compound. Then, for example, aromatic compound like nitrobenzene. Then nitrobenzene also can be reduced by using this method. One can use tin and HCl, or one can use iron and HCl. This combination, any combination one can use. And through these reductions we are getting amine. But generally when we reduction carried out, whatever amine obtained, it will react with a acid, and as a result we get a salt of amine, and this salt when neutralized by using a alkali, strong alkali, we will get amine compound. Sodium combined with chlorine and it remove in the form of NaCl. OH take H plus and remove in the form of water molecule, and amine will be obtained. So by using this method, one can prepare aromatic as well as aliphatic amine. Now suppose we have this structure. Now you can give the name of this structure. What is name of this compound? It is known as a 4-nitrotoluene. Name of this compound is 4-nitrotoluene. Now this 4-nitrotoluene on reduction by using a tin and HCl. Same method, we get this nitro group reduced into amine. Amine will be in the form of ammonium chloride or anilinium chloride will be obtained. When nitro group will be reduced, it convert into NH2 because of medium is acidic. NH2 gives NH3 plus and Cl minus, which on neutralization we get a final product, this structure. Now it is known as a name of this structure, we can give that it is commonly known as a para-toluene. Whatever structure obtained, it is known as a para-toluene. But IUPAC name of this structure one can give in this way, that amino group is present in 4th position, or we can give that highly reactive group is amine. So we can give name to the variety of name one can give. It is known as 4-methyl-aniline. 4-methyl-aniline, or it is also known as para-aminotoluene. Commonly it is also known as a para-aminotoluene. So it is commonly when amino group and NaCl3 is present, then common name of this structure is para-toluene. IUPAC name we can give 4-methyl-aniline. So it is observed that variety of nitro compound can be reduced by using this method, and as a result we get a amine compound. But nowadays this combination of iron and concentrated HCl is used. If we want to obtain highly pure product, then palladium and carbon use. Whenever we are using a nickel as a catalyst, then very high temperature required for reduction reactions. For reduction of alkyl nitro compound, we are using either lithium aluminum hydride or sodium borohydride. So a lot of example we can give. By reduction of nitro compound, one can get amine. Now second method of preparation of amine compound is ammonolysis of halide. Now we are knowing very well that carbon halogen bond in a alkyl halide as well as aryl halide is comparatively weak. So this carbon halogen bond of alkyl halide or aryl halide, it is observed that it can be broken in the presence of nucleophile. Can be broken by use of nucleophile. You are knowing very well what is meant by nucleophile. Then any negatively charged species which has a tendency to donate electron pair is known as a nucleophile. So now suppose we have this alkyl halide, then alkyl halide when allowed to react with excess of ammonia. When alkyl halide is allowed to react with excess of ammonia in a closed container, then this 2 mole of ammonia undergo self reactions, and due to the self reactions we are getting a NH4 plus and NH2 minus. NH2 minus, this nucleophile will be generated. This nucleophile substitute halide. So this halide reacting with the NH4 and it remove in the form of NH4X ammonium halide, and this halide substituted by nucleophile NH2, and as a result we get RNH2 and primary amine can be obtained. In order to obtain primary amine, we have to take ammonia excess. So when this ammonia is taken as an excess in proportion, then we get this amine. So by using this method, one can obtain a primary amine. But suppose we have not taken amine in excess proportion and alkyl halide is taken in a large proportion, then we are getting a mixture of primary, secondary and tertiary amine, and reaction occur in different way. Suppose we have taken ammonia, then this ammonia react with a alkyl halide. The mechanism occurs in this way. This halogen will attract the bond electron pair and nitrogen will donate electron pair to alkyl. So as a result, we get this type of alkyl ammonium halide compound. Now whatever alkyl ammonium halide compound obtained from this, amide can be obtained by using a concentrated solution of alkali. When this concentrated solution of alkali is allowed to react, halide combined with a sodium. Halide combined with sodium, it remove in the form of NaCl. This OH combined with H and it remove in the form of water molecule, and as a result we will get a primary amine. But now whatever amine obtained in our reaction medium, we have taken a alkyl halide in large proportion or alkyl halide is present, then reaction occur continuously further and same as we get a different type of product. Now what happened that this alkyl nitrogen donate electron pair to this and this halide take hydrogen, it remove in the form of HX, and as a result we get a secondary amine R2NH. Now further, this R2NH, if allowed to react with alkyl halide, then once again it donate electron pair to alkyl halide. Halide will remove with electron pair, it take by H plus ion and it remove in the form of HX, and as a result we get a tertiary amine. And whatever tertiary amine obtained, once again it is possible to react. Once again this tertiary amine is possible to react with a alkyl halide. Once again we get a quaternary ammonium salt. So it is observed that this is obtained is a quaternary ammonium salt. This quaternary ammonium salt will be obtained by using this method. So it is observed that in a reaction mixture, suppose we have not taken ammonia in an excess proportion, then drawback of this method is we are getting a mixture of, by using this method we are getting mixture of primary, secondary and tertiary amine. So by using this method, by using ammonolysis method, if we want to prepare primary amine, then ammonia we have to take in a large proportion or we have to take in an excess proportion. So now suppose we have this method, then I have taken, suppose here example I would like to give you, suppose I have taken here ethyl amine. Then ethyl amine, if allowed to react with ethyl iodide, ethyl amine is allowed to react with ethyl iodide, then reaction occur in same way, hydrogen combined with iodine, it remove in the form of Hi. And as a result we will get this structure CH3, CH2 twice and NH. So it is known as a diethyl amine. The structure whatever obtained is diethyl amine. Now whatever structure, this is ethanamine. IUPAC name we can give ethanamine, or IUPAC name of this structure we can give N-ethyl ethanamine. Now further it react. Suppose we have this ethyl iodide again. Suppose we have ethyl iodide again, then same way reaction occurs. This hydrogen combined with iodide remove in the form of Hi. When it remove in the form of Hi, and as a result we get a triethyl amine. So by using this method, generally we are getting a mixture of primary, secondary and tertiary amine. So this structure is known as a triethyl amine. चलो इसका IUPAC नाम हम दे सकते हैं NN diethyl ethanamine. One part is considered as a ethanamine, the remaining two part NN diethyl ethanamine. Now suppose from here, if diethylamine is allowed to react with a methyl iodide, if allowed to react with methyl iodide, then here hydrogen combined with iodine remove in the form of Hi. When it remove in the form of Hi, we are getting a different type of little structure, change obtained in this structure. Now whatever the product obtained is known as a here ethyl, N-ethyl, N-methyl, ethanamine. So name IUPAC name we can give. This is a N-ethyl, and after N-methyl, and remaining part is a ethanamine. We can say that the order of reactivity of halide, with a amine. We can say this order of reactivity of halide, with amine. That alkyl halide can easily substitute hydrogen as compared to alkyl bromide, and alkyl bromide can easily substitute alkyl chloride. So by using this method, one can prepare a different type of aryl as well as alkyl halide is possible to prepare. One conversion I would like to give you. Suppose we have a compound, this aniline or benzene amine. Now this aniline in a closed vessels is heated with a methyl iodide. When aniline is heated with a methyl iodide, then in closed vessels reaction occur in this way: hydrogen combine with iodine and remove in the form of Hi, and as a result we will get this structure, and name of this structure we can give N-methyl aniline. So N-methyl aniline, whatever obtained to us, it is a which type of amine? Yes, it is a secondary amine. Now suppose we have excess of methyl iodide, and further it heated with this, then here hydrogen reacting with iodine and removing the form of Hi, and whatever next structure obtained to us, it is N-dimethyl aniline. So this structure is N-dimethyl aniline. Now whatever N-dimethyl aniline obtained to us, it is which type of amine? Then it is tertiary amine. So it is observed that by using this method, suppose whatever carbon halogen bond is broken and we have obtained an amine, then amine can be converted into secondary amine. Tertiary amine is also possible to prepare. In one lecture we will study that suppose how this aniline can be obtained. Then aniline also prepared by using ammonolysis reaction. Suppose we have this chlorobenzene in a closed container. Now this chlorobenzene in the presence of nickel as a catalyst, and we are using very high temperature 873 Kelvin, is allowed to react with a 2 mole of ammonia. Then just I have informed that due to this self-ammonolysis process, it generates NH4 plus and NH2 minus. So now this nucleophile will attack on this carbon, and this chlorine with electron pair remove in the form of ammonium chloride. So ammonium chloride will be obtained as a byproduct, and this NH2 group joined with a phenyl ring, and as a result we will get a aniline. So by ammonolysis process, it is observed that by ammonolysis of chlorobenzene, one can get a aniline. But it is observed that this carbon halogen bond in aryl halide is comparatively strong as compared to carbon halogen bond in a alkyl halide, and because of this, more energy required to break this bond.